Hello, everybody. Welcome to Classes in the Session, a panel on democratizing cloud computing on campus. Before we begin, my name is Amanda Tan, and I'm the Research Engagement Program Manager for CLASS. We will start off with some logistics, a welcome, and an introduction to the CLASS program, and then we'll kick off with introductions to the panel, and then continue on with discussion. So before we begin, just a couple of quick logistics. For participants, your microphones and videos should be turned off, and please join the conversation and submit your questions via the Q&A tool at the bottom of your Zoom window. We will have time for interactive discussions at the end, so please use your raise my hand functionality and you will be unmuted. And make sure to unmute yourself as well if we forget to do that for you. So today's virtual event is also being recorded and will be made available on the past events portion of the Internet I2 online page. So with that, let's kick off with an introduction to CLASS. If you're not familiar with CLASS, CLASS is the acronym for Cloud Learning and Skills Sessions. Next slide, please. And today we're joined by panelists from three of the cohorts, one from the Cohort 1, one from Cohort 2, and one from Cohort 3. And so far, we've had 3 cohorts for CLASS. So some of the core goals of the CLASS program is to enable a broad research community that are able to leverage major cloud provider platforms, to empower, which is to strengthen IT research support and institutional capabilities, and to engage, which is the creation of a community of practice that's focused on the fast-paced nature of cloud. So today we will hear from the panelists about how maybe CLASS has helped them along this 3 E's, or whether or not the program goals have been achieved. The CLASS program seeks to bring together cumulative experiences from researchers and research facilitators and other members of the research community to build and implement a robust cloud curriculum. Next slide, please. Some of the facts for CLASS. So as I've mentioned, there's been 3 cohorts since January 2021, and our panelists today each represent one of those cohorts. There's been 44 institutions with 83 participants. Cohort 3 is currently in progress and is expected to complete by January. And CLASS is really in-depth training targeted for research, computing, and data professionals on 3 cloud providers: Amazon Web Services, Azure, and Google Cloud Platform. And CLASS encompasses 48 hours of structured training, including engagement with cloud provider teams to build and understand end-to-end research workflows and team-based projects. Next slide, please. And so with that, we will be introducing the panelists. I think we're going to start with the slideshows, and we're just going to look at faces at this point. So great, we'll start with some introductions. I'll kick it over to the panelists to introduce themselves and to tell us really why they joined CLASS and what their experience has been. So let's start with a representative from Cohort 1. Chris, you want to kick that off?
Sure. My name is Chris Lalande. I'm from the University of Wisconsin. I guess since I'm Cohort 1, I get to say we're number 1. My role on campus is a research cloud technician. So what that means practically is I run around campus and talk to researchers who think they might want to use the cloud for their research workflows, help them learn how to use the cloud in a very lightweight way, enablement, and then kind of turn them loose. So what I was looking for from CLASS was the opportunity to learn more about the clouds that I don't know as much, because we're a multi-cloud institution like so many, and the pieces that I hadn't yet gotten to play with. So that was definitely a wonderful takeaway for me from the experience.
Paul?
Hi, I'm Paul Williams from the University of Delaware. I work as a systems programmer in the IT Research Cyber Infrastructure Department. I came into the position just over a year ago from another department at the university. I'm mainly responsible for the system administration side of things, and I help out with researcher support as needed. My focus has been on integrating our Darwin cluster with Exceed as a level 2 resource and helping facilitate the use of cloud resources with the researchers. My supervisor actually suggested class to me as a training option. And after reviewing it, I agreed it would be a good opportunity to get some hands-on experience in all three major cloud providers. Think about using those resources from a research perspective and to get connected to other people doing the same thing at other institutions. The biggest benefits of class for me so far were increasing my confidence and knowledge in cloud computing and getting ideas just from hearing how other people are approaching it, tackling issues, the workflows that have worked for them, that sort of thing. It's made it easier for me to go into conversations with researchers, feeling equipped with the right mindset and tools to be able to answer their questions and ask some questions that they haven't considered and raise awareness about the resources that are available to help.
Great, thank you, Paul and Jacob.
Yeah, my name is Jacob Fosso Tande, and I am the Research Computing Administrator at the University of North Carolina, Greensboro. So this is my second year on campus, and as I work in the central IT, and I represent the researchers' point of view as far as cyber infrastructure is concerned. As far as class goes, so our university has been, especially on the enterprise cloud side of the IT, is really into cloud. And before I got to UNC Greensboro, they were already looking at using cloud to provide some of the resources needed by researchers. So when I got here, I just went into work, so implemented the Jupyter Hub for teaching and for use by people in the social sciences, the non-traditional areas of computing that the way we know of. And it's been a success and people like it. But at the same time, we have a cyber infrastructure lab where we provide credit for faculty, students, or researchers on campus who may be wanting to try their hands on cloud, using cloud infrastructure for their research. So we provide a credit and then we collect the information and we gather the information to be able to gauge how they use it, how much is being spent on the project, so we can understand how to better serve our users. So when class came up, I got the notice, I think, through Campus Champion, and our AVC got the note as well. So since I'm required to take a training per year, we just agreed that it was a good option for me to get into. So far, it's been a great experience. So I've been very much exposed to Azure, a little bit of Google, not much about Amazon, but with class, I've been able to explore all of the three, compare all of them, compare the three, and then I've been able to see what I can use when I can use Google or when I can use Azure or Amazon. And the most important thing which I had today was really setting up a workflow in an environment which is really typical and beneficial to a researcher, setting up a workflow in a Jupyter notebook so they can deploy the resources they need for the type of research they want. So far, it's been a positive experience for me. And I think our institution will greatly benefit from that as I go deep into class and taking the knowledge that I've learned back into campus. I think I'll be better equipped to serve my community.
Wonderful, thank you. Chris, I'm going to circle back around to you with a question. Since you were from cohort 1, which was way back in January, have you utilized some of the skills that you've learned in class to help researchers move your project along so far? And the answer can be no, but I'm just curious.
Yes and no. I think Jacob just touched on the thing that's most important that I took away from class, which was a deeper understanding of the differences between the three clouds and the strengths among them, so that I can help people make informed decisions about, okay, tell me more about what you're trying to do in the cloud and what your requirements are. And I can help guide them to, who has strengths in that area from a vendor point of view, or, even some of the trade-offs like, hey, I hear you saying Windows Virtual Desktop. Let's not talk about anything but Azure until we've ruled Azure out for some reason, because licensing is a thing. But understanding some of those strengths and differences between the different clouds on a much more intentional basis, instead of just which one did I happen to use for what, and what service name do I know of, like, you know, some Greek god in the Amazon services stack that I happen to know is serverless data. Being able to compare them really, really intentionally has been the biggest help for me.
Wonderful. And I just wanted to remind participants that if you had questions, to please post them in the Q&A. We're monitoring that. I guess maybe, Paul, I had a question for you, which is, you know, you talked about that you worked with HPC systems. How have you, or haven't you, dealt with researchers coming to you and saying, like, you know, can you articulate why I would want to move my workflow to the cloud versus HPC? How do you navigate that conversation? Maybe you can offer us some pointers.
I would say I actually haven't had too many researchers coming to me asking me to articulate that aspect of it. Most of them that come to me, they're ready to go. They just want to move to the cloud. Most of those discussions have actually been internal with my team, and class has been helpful in that aspect, in terms of just being able to speak to them about, okay, well, here are some kinds of workloads that are going to work better in the cloud. Sure, we probably don't want to move everything there, but if somebody has a, you know, fairly simple need and our current clusters are too complicated for them, then yeah, we can do some pretty straightforward workflows in the cloud that will enable them to get going quickly. It won't cost a whole lot of money, and we can keep it secure at the same time. It was actually funny that Chris mentioned Azure Virtual Desktop, or a Windows Virtual Desktop. I just set up a project with Azure Virtual Desktop, and that was that kind of scenario where we had a researcher who just needs a place to collaborate with another researcher. And we were able to set that up pretty quickly because I was comfortable moving around in there. I knew what to look out for. We looked at AWS, and I was able to compare, you know, all the options I would need to consider there, and things like authentication and how we're going to get people logged in, all that kind of stuff. A lot of that background knowledge came from the things I was able to do in class. So that was really helpful in that perspective.
Great. Chris, Jacob, do you have anything to add to that question?
Yes. So I'm just going to go with a very popular African saying that says, the most important thing is not to know everything, but to know where everything is. And I think class is actually providing all of that to me. I'm going to take one scenario. So generally on campus, we spend a lot of money. The traditionally has been on capital investment, on getting the servers, the desktop, but we don't really think a lot about what operational costs. If we are running a class, for example, and you are a department head, you have a budget for a class, maybe if it is a class that's just going to run with 20 students, or you're just spinning up, I don't know, a server for a database so people can have access and practice using a database, the class may be, a cloud may be an option for you, cost-wise, if you set it up correctly. And that is what this being part of class has really helped me reinforce that belief. And I think there is an option there, not just on capital investment, but operational costs as well, as a way of looking at providing computing resources. And of course, so if you go the operational way, you are not, you don't stay with the same infrastructure. You get new infrastructure, new type of systems, and you have options. And I know the complaint most of the time has been what? The cost. It's expensive. And with class, not only you know where the resources are, you equally, so you equally know how to manage the accounts, set up the system in a way to optimize costs, to minimize expenditure, and then use the resources when you actually need them. So, yeah.
I think one of our panelists is missing, but we'll just carry on with two panelists until Chris joins us back. I think we want to come back to the issue of cost. I think this is one of the challenges in, I heard this terminology yesterday, not cloud adoption, but even cloud transition. I wonder if either of you can weigh in on how do you have this discussion, how do you approach this discussion about cost in terms of which cloud provider should I choose? How do I calculate the cost? Either one of you want to weigh in on how do you approach this question?
For us, the question of which provider to choose depends a lot on their needs and maybe some of the technologies that they're interested in. So cost hasn't been the primary deciding factor there. And while there are differences, they're pretty close. So that's, I still feel like the project requirements are going to drive that more than the budget. Sorry, what was the second half of the question?
I think you should just continue your train of thought. It was just really about the question of cost and how do I choose which cloud provider?
Yes, an estimate, estimating the cost, how do I figure out what that's going to be? So that is tricky. I haven't found a good solution for that because they all have cost estimators that you can use online. But to use those effectively, a lot of times you need to know exactly what resources you're going to use. And sometimes you don't know that until you get into setting things up, because you'll set up one service and you'll find out, oh, if I'm going to use this and I want to, for example, turn on backups, well, that is going to turn on these other two services that I'm going to have to also estimate. And you have to have an idea of how much data is going to be going through, all that kind of thing. So what I've been doing with the people I've been talking to is give them some rough estimates and ways of calculating it on the fly to just say, hey, if we turn on backups for this VM, you know, it's going to be $10 a month plus we have to pay for storage. This is how what storage is going to cost per gigabyte per month. So that gives them a chance to at least, you know, do some rough estimates. And then I'll usually throw in an estimate and say, it'll probably be somewhere between, you know, $30 to $40 or $50 a month for this, the machine that you've got now. So that seems to be helpful. It gives them enough information to make an informed decision without having to know exactly like, you know, what the annual cost is going to be when we're not sure yet.
And I think Chris is back and she's on a very, very small screen. So I have to squint to see her. But Jacob, do you have something to add? And Chris, just to catch you up on this conversation, we're talking about costs, which is one of, depending on how you look at it, might be the most interesting or the most annoying thing about transitioning to the cloud. So I was wondering if maybe you had, I don't want to put you in a spotlight, but did you have something to say about that?
Yeah, and stop me if I'm repeating what my colleague said. I would say it's both. It's both the most interesting and the most annoying part of cloud. One of our challenges, which I think is fairly common around a lot of campuses, is like Jacob was saying earlier, total cost of ownership is not something that universities are great at. And that's the language that cloud vendors tend to speak in all the time of, oh, it'll be cheaper to put that workload in the cloud because then you don't have to have a data center and you don't have to have a this and a that. Except my researchers are only really need to care about the cost of their own grant. And right now, if our HPC cluster is free to them to use, and the cost of ownership is being borne by the university, to the researcher, high performance computing at UW-Madison is free, and high performance computing in the cloud is very, very not free. So navigating some of the whys and some of the understanding there, as well as educating our vendor partners on the language they use when they're talking to higher ed about price and about, you know, total cost, is really, really nuanced and can be really, really tricky because the local economy at a university influences that so heavily, in addition to what the cost of running a workload in a cloud would be.
So we actually have a question, but I wanted to riff off of that a bit because we're talking about democratizing cloud access in campuses. And I feel like education, right, not just for research facilitators, but educating even administrators, educating just every level of the campus community and even the vendors is something that needs to happen. And I wonder if either any three of you have thoughts on how do we go about doing that? What are the levels of education that are needed? Is it separate talks? Yeah, just trying to get an understanding of what kinds of education and what levels of that are necessary. If you've thought about that.
Yeah, so I'm going to jump in here. I think the level of education, yeah. So what the common way of doing things is having a vendor or a cloud provider come on campus and give a presentation, talk to people. But then the challenge is actually getting people to try things. So you can say all the good things, but really adoption will depend on how people feel comfortable. I mean, we all know that on campus, when people start doing things one way, it's really hard to get off of that. Even when it's clear that the other option is really a good option for them. So our approach at UNC Greensboro has been to put some money up front, bring in researchers, have them just as if you want to run a job on an HPC, so you have a startup, you try it out, you understand the parameters of your job, and then now if you're going into the cloud, you do the same. You set up an environment. We call it the Cyber Infrastructure Lab at UNC Greensboro. So we give you a location, you run a sample of the work that you're planning on doing in the cloud, and we pay for it. You don't have to pay anything. The only constraint is that you share the data with us. So if next time somebody comes with the same kind of workflow, we know exactly what to expect. And we equally provide support, so technical support, because one of the challenges in bringing people to adopting cloud is you want me to do the research, but you equally want me to build the environment. I'm in for the research, not for the environment. So if we provide the technical support, we want you to focus on doing the work, and we'll provide the technical support. So you only use the environment for what you are expected to do. And so I've been looking around because I think the NSF and other federal institutions are looking at cloud as well. I think Cloud Bank is an example. I think during one of the workshops, my suggestion was maybe adopt the approach that Exceed and the Campus Champion have adopted, where you have a credit upfront where people can test things, and when they feel comfortable, then they can apply for, I don't know, time or a resource time to use the system. So if Cloudbound is something like can adopt a system similar to Exit and Campus Champion, then people have incentive to try things. Now, if somebody is writing, I don't know, a grant, and they want to use cloud infrastructure for their research, if they didn't do some sort of pre-data analysis or tests, it's really hard to estimate how much of the resources they're going to use. I mean, barely having an idea and then maybe extrapolating with some degree of uncertainty to make sure you know what you're doing. So I think if we put in place these type of incentives, then we encourage people to, yeah, what I've seen people tend to use. But the downside of it is, if you don't get it right, if you're trying to convince people to come and use a cloud service that you've set up, if you don't get it right, and then they start running, I'll take, for example, Jupyter Hub. They start running Jupyter Hub, you start spinning the work environment and it fails. I think one of the things I hear is, oh, it's another piece of crap. So you have to get it right. And then getting it right is building the environment, testing it, using the standard, making sure everything runs well. There is no 100% guarantee that it will run, but at least you have a degree of certainty that things will run the way you expect. Now, if they come in and they use it and it works perfectly, you are not the one to sell. The faculty or the researcher that has used that infrastructure will be selling it for you.
I think this ties into a question that we received, which is how frequently do you encounter some of these instance mismatching? So for example, you said, if we spin up a Jupyter Hub and it's crap and the researcher doesn't want it, how often do you encounter that, and what happens when that happens?
Yes, so I think you shouldn't be afraid to tell people the truth. So you tell them, this is, if you're just starting the development, which that happened when I was just starting, when I just started building Jupyter Hub, and I was new to that. And so I tell them, so if you don't tell me what is wrong, I won't know, and I won't make it work better for you. So if you see an error, send me the error message and I'll figure out what it is, and then we'll build it. So working consistently across, and I think I had, once that incident happened, then COVID hit. And the Jupyter Hub now, people who didn't believe in it, they figure out it was the main area, especially the social sciences, or people teaching online classes or long distance classes. So they started using it. And I equally had to look for different ways to help them use it. For example, helping a student who's programming, but is stuck and can't change anything. So I gave my faculty administrative privileges on the notebook. They can access the hub and see what the student is doing. And they can actually run the command and the student sees what they're doing. So when I work with two faculty that were really interested in that, and the result was really positive. So I invited them for a presentation. All the other faculty that had interest in using Jupyter Notebook attended the presentation session, and they left with very positive view, even though some are still reticent just because it's something that is new. They like the idea, but just because they have to learn how to use Jupyter Notebook, I mean, they want to stay with what they are used to.
I realize that this is a conversation on class, but I also want to make a plug for Jupyter Notebooks and Jupyter Hubs. They will change your researcher's life. And I wonder if Chris or Paul, if you wanted to just expand for a few minutes about that. How do you deal with, I think this is a really good question, that if you start going down one track and you realize that you're wrong, how do you pivot, or how frequently have you had to deal with this? Do you want to chime in here, Chris?
Yeah, I can do a quick anecdote on that. The virtual desktop scenario I was just talking about, the researchers came to us saying, we want to use AWS. Once we started digging into finding out exactly what they needed to do, and then understanding some of the limitations we were going to run into, thinking about how we're going to handle authentication, logging in, external users, and how they would access these resources, we came back to them. And I think the key was just communication. We were constantly communicating with them to say, hey, I'm looking at this, but I'm not sure this is quite going to work. Here's what I think will be a good option. I'm going to talk to a few people. I had to reach out to some other resources then, but I was keeping them in the loop so that they understood, we have reasons why we're saying this is probably not the best way to go. Here are our reasons, and here's the solution that we've come up with. Does this look like it's going to work for you? And that worked out well for us. So we were able to come to something that they could, we could all agree on, like, this is going to be a better way forward. And on the other side of it, so even though, like, I got them set up with the Azure thing, I started them out on a burstable instance, but I told them, like, this is not going to be a great experience right off the bat. There's a limit on how, with those instances, on how long you can be at 100% CPU utilization. But I want you to start out with this. It's a cheaper version. You can get your feet wet and make sure you're comfortable. And when you're ready to do some real heavy workloads, then we can change that easily. It's not a big deal, but just let me know. So I think, laying the groundwork, communicating, and just being clear about what limitations they might need to expect helps to set the expectations at the right level.
Yeah, and Paul, I'm going to yes and you. I had a research lab come to me recently saying, hey, we need an instance, we need a VM to do X, Y, and Z. And in talking to them, it really rapidly became apparent that really what they needed to do was run a database. And because they're so used to, first you have a box, then you have an operating system, then you install the database, then you can start to build your database. They came to us with really fleshed out requirements, but at the end of the day, what they wanted to do was to be able to run Postgres and manage their data. So in talking through them and talking through their staff levels, at the end of the day, we ended up doing a managed database in AWS. So that takes off of the lab's plate, keeping a server patched, keeping a database patched. And yes, when we first looked at the cost of a managed database in AWS, they had the same reaction that everybody does, which is, oh my gosh, that's so expensive. But once you start to talk through all of the things that those technologists and those researchers don't have to do, and they can spend more time on their science, they ended up going with the managed database service because it frees up really valuable staff time for them. But it took a very in-depth conversation, to your point about, so you say you want an instance, what are you going to do with it? And, that was a fairly significant consulting engagement. The challenge there, like you said, is how does that scale? And, the more researchers on campus have that experience with cloud, then it starts to just propagate around campus of, hey, have you tried this? This thing is cool. And it's less of us doing that heavy hands-on engagement at the beginning, but it takes a little bit of requirements gathering before you should even be going there.
Yeah, that ties back into something I wanted to touch on with what Jacob was saying earlier on the education side of things. A lot of times people don't even know what's possible. They don't know what's available. They just know what they know, and that's what they want to have done. They just think, oh, it'll be faster in the cloud, or I can get it. I can get it faster than ordering another node on the HPC cluster. But when you really start digging into it, you find out that, okay, maybe your needs are different than what you think they are. And it takes a lot of communication, talking, and sometimes they don't even know the words to put to it to make it clear to the technical person, oh, this is what they're really talking about. So it does take some time. But on the education side, what I think is really helpful on that front is success stories and failure stories. Seeing what has worked for other people, and also what didn't work along the way. I'm speaking just personally, that helps me think about ideas or ways of using these different tools that I might not have thought of before. So that's like a community resource that we can all contribute to that really helps. And it's something you can easily point to. You say, oh, hey, sounds like you might be really interested in this group's work that I heard about from a different university. So that's one way I think of helping on the education side, is just helping people realize, oh, that's why this is such a useful tool. And yeah, the managed database kind of thing is perfect. It's like, yes, it costs twice as much for the same specs, CPU and memory, but you don't have to worry about backups. You don't have to worry about updates. You don't have to, there's just so much time that gets saved that it's going to be worth it, most likely, unless you have, an expert sysadmin who's, up to date on all the latest tools and they're on your team and that's all they have to do. Then sure, maybe, you can go to roll your own.
Maybe this is a good time to answer one of the questions, to talk about one of the questions that we have. And Paul, you mentioned education. So educating about workflows is one aspect of cloud adoption on campuses. One of the questions says, I'm curious about training and educational approaches for billing and account management. While we can modernize many components of a cloud research enterprises, our office research is still the core bottleneck in terms of costing models, accounting. So do any of you have an opinion on what kinds of educational training approaches that would be helpful in terms of moving that aspect along? And maybe you don't, which is absolutely fine. That's a very difficult.
So as far as training about account management is concerned, so I think how effectively you manage the account, I think from my experience, comes with your experience doing it. So the more experience you have, I think the better you are at managing account. And secondly, so all the cloud providers do provide tools for managing cost, and you should take time to go over those tools. I'll take for example, Azure. So they will usually give you suggestions, for example. So if you're running a Kubernetes cluster, for example, and sometimes when you check, they make suggestions. So we think this is a good option for you to cut down on cost. And if you're running a system for a certain amount of time or for a given period of time or a number of workflow, you pretty much have an idea. Now, secondly, I think the other point that I would like to raise here is there are people in the community who have the skill set, especially as far as research is concerned. So if you have a research project that is funded by the NSF, or you're supposed to use cloud, I think Cloud Bank does such a good job of taking care of managing the account for you. They have the tool sets in place for you to see how much you're spending, where you are, and it makes things really easy for you to understand. So not only you have all of your cloud provider, all the services that you're using. So if you're using Amazon, if you're using, I don't know, Google, or using Azure, you see all of that right there in front of you. And also, I think one other way that the cloud providers help is you can set a limit on an account. So such that when you hit that limit, well, the services stop. So that is another way. But from my experience, you become good at managing an account depending on how well you've been using the services.
Thanks, Jacob. Chris, your hands have been up for a while.
Luckily, it's a virtual hand. Two things I'd add to that. One, just like my colleagues were saying, we don't have limits on our accounts, but we do ask people when they apply for accounts to tell us a threshold where they want to be alerted about their spend, so that we're proactively pinging them saying, hey, you're at $100. Hey, you're at $1,000. Because they're not going to be watching it closely. The other thing, and I'm just going to blatantly shill for somebody else's presentation, the Cornell Cloud Forum a couple weeks ago, UCSD did a really interesting presentation about financial management in cloud, and I would love to replicate what they've done, in all of our spare time with all of our spare funding. But they have someone who had a finance background, who's learned enough about cloud optimization and enough about cloud finance to be able to be actively monitoring places where they could be doing bulk discounts or other things to optimize the accounts, which we all know the tools are out there, but it's the time to go and look at, okay, is the University of Wisconsin at enough S3 storage that we should be talking to Amazon about private pricing for the university? Probably, but I don't have time in my data to go and look at that on a regular basis. So the idea of bringing in someone with a finance background or an accounting background instead of a technology background and training them in the cloud piece, I thought was really compelling. So go Google Cornell Cloud Forum and find the financial ops presentation.
Fantastic. I want to pivot away a little bit from cost because we're going to revisit this again. I'm pretty sure it's a never-ending question. One is, at your institutions, are there discussions regarding hybrid cloud and cloud bursting? Sounds fun. That is extending your HPC cluster to public cloud resources. And
Not directly, but there were some discussions in my class cohort about it, and some work that we've been fiddling with, I'll say, after hours, to look at doing that with Kubernetes clusters bursting to the cloud, but nothing directly at our institution.
yeah, Chris?
I think it's same with me. So we do not have that need on the research side that I we don't have that need on the research side. So if anything, hybrid, I think of it as infrastructure that if we really want to build on-prem, it will not be cost effective. I'm thinking here of a secure research computing environment where the cloud providers, they already have most of the infrastructure in place. So we can build off of that. It makes sense for us because we don't have the manpower and the time and all the resources that we need. So if the cloud people provider come in, it's a quick, and we can even start small, and then as our needs grow, then we can expand or scale as need be. So that is my hybrid take on cloud. So we have on-premise resources, and then we have cloud infrastructure that needs specific needs, which I think I'm one of those who believe there are pure problems for cloud resources, and there are pure problems for on-prem, and you can't trade any of those.
Great. And Chris, you want to quickly chime in before we move back to the discussion of cost?
Yeah, I think they mostly hit it. I think the one place where we may start to see it is if it continues to be as hard as it has been to get physical purchases, particularly of GPUs, then we're going to start to see our big HPC clusters have more and more interest in that. But I don't think on the HPC side of the house, we're seeing much of that. Where we are starting to see it is a little bit in storage and archival storage being really, really cost competitive for genuine Glacier storage.
Yeah, actually, can I touch back on the hybrid cloud too? Because we're looking at similar things as Jacob's talking about secure compute environments. And yeah, to speak to what Chris said, our latest cluster expansion, we're looking at a 30-week lead time, I think, on ordering new hardware. So, you know, maybe our discussions will change in the future.
Let's pivot back to the question of cost. And I know both Paul, you and Chris, you both have worked on the Strides program. And did you find like programs like CloudBank and Strides provide lower cost to researchers? And Jacob, you might have also, might be familiar with CloudBank or Strides. Did it provide lower cost to researchers other than your own agreement with the cloud providers? And have these programs been effective or manageable?
You want to start, Chris?
Sure. In Google Cloud, Strides is an awesome deal, and it was super, super easy to put into place because of the way Google Cloud's billing works. For Amazon, it's been a little more problematic for us, partly because we work with one reseller and Strides is through another. So that involves us having a whole nother reseller. And the discounts aren't as deep. We haven't gone there with Azure yet. The biggest challenge with Azure for us is right now, you can only have one Azure enrollment for the university. And by that, I mean capital E enrollment in Microsoft. And we already have two separate enrollments, one for the university and one for our School of Medicine and the high risk data. So we're currently thumb wrestling over if there's only one Strides discount to be had, who gets it, which is not a great situation for the university to be in, though we did give that feedback back to NIH, and it was pretty clear that we're not the only ones saying, hey, this isn't going to work. But Strides and GCP is awesome. Do it.
We're working on setting up Strides with AWS actually, and we have a negotiated agreement with AWS, but the discounts we got through Strides were better. I wouldn't say significantly better, except on the storage side of things. You get a pretty nice discount on the S3 storage through Strides with AWS. So yeah, I would say do it. It is a little more work, but the reseller we're working with has been really helpful, and it's another relationship to manage, but they're willing to help us on the billing side to make sure that they can streamline things as much as possible for us. And they've made the getting things through our project management department and all the people that have to give their okay, they've made that very easy as well. So it's worth it. I can't speak to Cloud Bank though, so sorry about that.
Fine. Well, let's move on to another question, which I think, Jacob, this might be something that you can help us understand. Is what has your experience cost-wise been for things like managed database services that Chris brought up earlier? And when you have services like this, how are the costs compared to cloud alternatives?
Yeah, so I haven't really used the managed database. So most of the managed services on our campus is with the enterprise infrastructure. So most of my work is basically me picking the systems that fit the type of research that is of interest to me and building whatever environment I need to build on it, and then deploying it for our researchers to use. So I generally would just run through and make some sort of flow chart comparison. So I have access to Google Cloud and I have access to Azure. And there are certain services that Azure will give me a good deal, whereas Google won't. Or there's services that Google will give me a good deal and then Azure won't. So if I'm running my Jupyter Hub, for example, in the cloud, where I have the option to create an instance for anybody or any class or any person doing a specific type of analysis. So I have that cluster. If I'm just running using the VMs on pay-as-you-go, it costs a lot for me. But if I do a reservation, I pay less. So those are options that you look at. So I can just lock down my base VM. I know I've been running this for 2 years, and I know how much resources are used by my users. So I can make a good guess to know how many nodes I need to lock down, and then pay for that for 1 year or 2 years, and that reduces the cost significantly.
Chris, Paul, did you want to add?
We don't have any on-premises managed database services, so I don't have a comparison there. But I think it actually touches on your second question, James, about the economy of scale thing. So I think that's one of the situations that we're facing, is we don't have the economy of scale to do a bunch of on-prem managed services. We have VMware infrastructure, so we can get people started with a VM, but we don't have managed images for them. Like you get the bare bones and then you're off, and hopefully you know what you're doing. And we have our security teams doing scans and that kind of stuff, but there's a lot of responsibility put on whoever's purchasing those resources from our central IT department. So in that case, when you don't have the people, or we're bumping up to resource limits on our data centers, so we're running out of space, we're running out of cooling. If you don't have room for that, you look at the cost of expanding or creating an additional data center, then cloud looks pretty attractive. So I think it does depend a lot on the situation that you have at your institution.
Well, and I think it also depends a little bit on the diversity of needs. If everybody all over our huge decentralized campus all said, we're all going to run MySQL, and that's the only database we'll ever use, then would we be able to staff up and cost effectively run, a suite of MySQL databases? Maybe. On the other hand, at least my researchers, they all have their special thing that they're used to using. And I don't mean that to sound pejorative, because they have research to get done. They shouldn't be learning about databases. They shouldn't be spending their time on, learning the technology that I say that they should use. So since we have a really heterogeneous environment, we have lots of different needs. That's where the managed services really help, because then we can say, you want Postgres? Go for it. If that's the one cool. Use the managed service so that we don't have to patch it. We don't have to have Postgres app experts on campus. And then when the new hotness comes along, we don't have to learn that one either. It's just easier to pivot that way. because we just have so many different needs all over campus.
Wow, we're almost at the top of the hour. Oh, go ahead, Jacob.
Yeah, so I'm going to add. Yeah, I'll quickly add that for as far as economy of scale is concerned, whether there is effectiveness or efficiency. So I have that concern too, and when I was searching, I don't quite remember the paper, but there are a number of publications out there. People have done editorial analysis. And most of the time, HPC in the cloud doesn't make sense, at least from what I read. And then other services, yes, you may be, that may be cost effective. So I'm thinking here, for example, I don't know, maybe edge computing, where you have a number of sensors deployed all over the place, and you want to collect data from all those sensors and send into a specific location. That may make more sense. But if you're moving your HPC to the cloud, that doesn't make much sense per the paper. Yeah, I don't have really have the citation of the paper, but it's out there. So I just Googled and came across it. It was really interesting to read and see that people have been working on that.
Just sounds to me that there is, it depends on the use case, right? Whether or not you move to cloud, it just depends. So I think in our last few minutes, I wanted to have a quick lightning round. Again, this is a conversation about democratizing cloud adoption on campuses. And 60 seconds, we're going to talk about what else can the class program help you with to make your life easier. Is it more training for researchers? Is it more billing management? So 60 seconds, thoughts?
I think that one of the most valuable things I got from the class program wasn't content, it was the network. It was going through it with other higher ed people. So I think continuing to lean into that cohort model. So, you know, back to Jacob's point of you don't have to know it all, you have to know where to look. Sometimes it's also who do you ask? I love the connections that came out of that program. That's critical to me.
I would say the success stories, examples kind of thing that I mentioned earlier, more of those that I can use as marketing material maybe would be really helpful. And then, yeah, the cost accounting, I think, is probably the biggest area that I still feel least prepared for, especially when you're talking about dealing with all three cloud providers. Like we want to support all three. Well, that just complicates things even more. So yeah, again, examples of institutions that have done well at that, approaches that work well, third-party tools, whatever would help with that sort of thing.
Yeah, so I think my 60-second is have a repository of all the interesting tutorial. I run through them. Some are great, some maybe you need some time, but you go through it, it's fun, but down the road, you get a sense when you're actually solving a real world problem. And sometimes you want to take a look at what you did in the past. So if that is readily available where I can just say, oh, I did this when I was in a class program, and I can just go there and take a peek and then come back and keep doing what I'm doing.
I'm taking so much copious notes, and hopefully, the next iteration of class will have all these topics that you great panelists talked about. And I just wanted to thank Chris, Paul, Jacob. This has been just such a productive conversation. At least I got a lot out of it, and I have a whole bunch of notes. So again, thank you so much. Thank you to everybody who attended. And if you have questions, please shoot us an email at class@internet2.edu. And I think this is the end of the panel. Thank you again to the great panelists. Thank you for your time.